Hello students, welcome to today's lesson. My name is Teacher Alice and today we are going to start on a very new topic, and this is the last chapter of Form 3 work. So this is chapter 6 of Form 3 chemistry, and the topic is chlorine and its compounds. So this is the first part, so we are just starting it today. So this is part 1, and we are going to look at chlorine. So we have seen chlorine previously from the first 20 elements, and we can give at least some properties of chlorine, or when you are asked about chlorine, at least you can say something. For example, you know that chlorine is a nonmetal. So chlorine is not a metal, and it belongs to group 7 of the periodic table. So that is something that is from the Form 2 knowledge, okay, from the periodic table. Then we also know that it has an electronic configuration of 2:8:7. And from the configuration, we can see that it forms its ion by gaining one electron. So it forms its stability, it forms its ions by gaining an electron to gain the stable configuration of 2:8:8. So that is chlorine. It forms an anion, that is a negatively charged ion. Then it belongs to the group 7, the halogens. So the family, or the family name of that chlorine belongs to is the halogen. Then where do we find chlorine, or where does it exist? So it occurs one as brine. So brine, this is the concentration of sodium chloride solution that is dissolved in salty water. So like the Lake Magandi, we have brine where we have we mine our salt, we get our salt that is in Kenya. Lake Magandi is in Kenya. So even in oceans, we know that the Indian Ocean, that the water is salty, so we can also find chlorine in oceans and in lakes. Then also we have it occurs as a rock, salt solid sodium chloride crystals. It is found in the Earth's crust. Then we can prepare chlorine gas. So we can prepare it in our school laboratory, and we can do this through the following. The first method, we can prepare chlorine by heating solid manganese 4 oxide with concentrated hydrochloric acid. That is one method to prepare chlorine gas, heating solid manganese 4 oxide with concentrated hydrochloric acid. Second, heating lead 4 oxide with concentrated hydrochloric acid. So all these we are heating them with concentrated hydrochloric acid. Third method, or that way we can prepare chlorine, is by reacting potassium manganate 7 with concentrated hydrochloric acid. Then the fourth way, or the fourth method we can prepare chlorine gas, is by reacting either sodium dichromate or potassium dichromate with concentrated hydrochloric acid. So these are 4 methods we can use to prepare chlorine in our school laboratories. So one thing is that the 4 things that, or the 4 products, the reactants we are reacting, the reactant we are reacting with hydrochloric acid. These are what we call the oxidizing agents. So these this, what we have, manganese 4 oxide, lead 4 oxide, potassium manganate, potassium dichromate, sodium dichromate, all these are oxidizing agents. And they oxidize hydrochloric acid, they readily oxidize hydrochloric acid to give chlorine gas. So we are going to look at a general preparation method of chlorine gas using that we can use to prepare using all these oxidizing agents, the 4 of them. So here we have a setup. This is a setup for an experiment to prepare chlorine gas. So here we have concentrated hydrochloric acid that we are going to react with the oxidizing agent. Then there must be a source of heat, so we must heat them so that they can react. Then producing a gas, so this delivery tube will carry the gas that is being produced here through a conical flask containing water. Again, the gas moves to another conical flask containing concentrated sulfuric acid, and then we can collect our chlorine gas through a gas jar, and we are collecting chlorine gas through a method known as downward delivery method, or what we call the upward displacement of air. So we are going to see why do we use concentrated sulfuric acid and why do we use water? Yeah, what are the purpose of concentrated sulfuric acid, or what is the purpose of water? Then we are also going to see the reason why we are collecting our chlorine gas by the method downward delivery method or upward displacement of air. So this is a general setup that we can use to react hydrochloric acid and any of the oxidizing agents, any of the 4 oxidizing agents. Okay, so we are going to discuss the preparation of chlorine through these questions. So we are going to look at the preparation and also the physical properties of chlorine gas using the questions that we have here. So question number 1, what is the color of chlorine? So after the experiment, we are going to see that the gas we are going to collect is pale green. So the color of chlorine gas is pale green. Okay, the second question we have is to describe the smell of chlorine. So we are going to smell a very irritating smell. We call it a pungent irritating smell. So chlorine gas has a pungent irritating smell. Okay. Then the method used in correction of chlorine gas, we say it is downward delivery method or the upward displacement of air. You are asked to give a reason or to explain. You say that chlorine is denser than air. So the reason we use downward delivery or upward displacement of air is if a gas is denser than air. So chlorine is collected by downward delivery method. Next question, what is the purpose of concentrated sulfuric acid? So we saw that we are passing our chlorine gas through concentrated sulfuric acid. So what is the purpose of concentrated sulfuric acid? It is to dry the gas. So that is the purpose of passing chlorine gas through sulfuric acid. So it is a drying agent. Sulfuric acid is a drying agent. Roman 2 of that question asks us to name 2 other substances that can be used in place of sulfuric acid. So in short, we are being told to give two other drying agents of chlorine. So the two other drying agents are calcium chloride and silica gel. So we have three drying agents of chlorine. So we have concentrated sulfuric acid, we have calcium chloride, and also we have silica gel. Okay, then Roman 3, we are told to name a substance that cannot be used in place of conc sulfuric acid, and then you explain why. So many students confuse the calcium chloride that we said is a drying agent with calcium oxide. So calcium oxide is not a drying agent for chlorine gas. So any other substance, any other drying agent, that is the three but not calcium oxide, can be used to dry chlorine gas. And the reason why calcium oxide is not used to dry chlorine gas is because it reacts with chlorine. So we cannot use it to dry chlorine gas. Okay, next question. We are told to write three possible reactions between concentrated hydrochloric acid and the oxidizing agent. So this is just a matter of writing the reaction between the four oxidizing agents that we have named. That is potassium permanganate, potassium dichromate, sodium dichromate, lead oxide, with hydrochloric acid. So to produce chlorine gas. So this will be the products. These are the chemical equations for the reactions. Okay, next question we have, why is hydrochloric acid used in all the above cases? So why are we not using any other acid apart from hydrochloric acid? So this is because oxidizing agents such as the potassium permanganate and lead oxide, potassium dichromate, sodium dichromate readily oxidize hydrochloric acid to chlorine, themselves being reduced to their chlorides. All right. So when we have potassium permanganate or potassium permanganate reacting with hydrochloric acid, it will oxidize hydrochloric acid to chlorine, and itself is going to be reduced to what? Potassium chloride. So these oxidizing agents are reduced to the chlorides and they oxidize the hydrochloric acid to chlorine gas. They readily oxidize hydrochloric acid to chlorine gas. So that is the reason why we use hydrochloric acid. So this is the general equation, chemical equation for the reaction between hydrochloric acid and the other oxidizing agent. So you can see they give an oxygen to when hydrochloric acid is reduced, it reacts with the oxygen from the oxidizing agent, then itself is oxidized to chlorine, while water is also formed in the reaction. So we are going to have hydrochloric acid being oxidized to chlorine gas, and then the oxidizing agent reduced to its chloride, and then there's also formation of water. So that is how chlorine is prepared in the laboratory, and some of the properties of the physical properties of chlorine. So in any case, you are required to give an experiment or to illustrate or to describe an experiment for the preparation of chlorine gas. You have to use an oxidizing agent and hydrochloric acid to give the chlorine gas, water, and also we have the chloride from the oxidizing agent. So that was part 1. We have looked at the preparation. We have introduced chlorine, how we prepare, how it occurs or where it occurs, the physical properties, and the preparation of chlorine gas. So that is part 1, and in our next part or in our next lesson we are going to look at the physical properties of chlorine gas. See you in the next video.